And so I thought it would be great to just start this off with a hot take, which is that you should really consider LLMs to be hallucinatory by default. Like, unless you prove otherwise, just think of it as an hallucination. So I used to be a PhD student a while back, and like we really spent several decades of ML research trying to optimize models for generalization. How does it do well on new data, create new data things it's not seen before, and actively penalize memorization? So you really want to make sure that your model really does new things well and not memorize stuff. So there is an overlap between these two, and it's really, really murky, to be honest. And it's not clear what's in that overlap, what's not in it. And let's look at some examples. One thing I love doing whenever a new LLM comes up is to do some vanity searches on it, see how well I'm doing. So we asked Claude 2, which came out a couple of days ago, which is who are the founders of TruEra. Hoping to see myself on it, and honestly, I came away a bit offended. It got the first guy right and bumped me off of the list of founders. I also found out that my company was acquired 4 years ago, and that I just found out about it. So if I ask the same question about Google, which is a slightly bigger company than us, been around slightly longer, it gives you a really nice answer. So the thing is that what's going on here is that Google is in that nice intersection because it's general memorization. The TruEra question is not, but it's really hard to tell what it's doing well and what it's not. So I would say Claude 2 did its job perfectly. It came up with a really nice answer to a question it knew nothing about, and this is exactly what it was built to do. So I just say this is a feature and not a bug. So if I go to sort of the takeaway from this, LLMs are trained to generalize, and they sometimes happen to memorize as a side effect. So as a result, they sometimes happen to not hallucinate as a side effect. So that's just very important to keep in mind. Like they're not designed to memorize, they're trained to generalize. So what should we do about this? What we should really be thinking about is to focus LLMs on tasks which are generalizable. So things which are generalizable are things like summarization, creating embedding of text, creating inference, planning. There's a lot of cool stuff which doesn't require memorization. And then if you let LLMs focus on those, then you leave the memorization to something else, which is why LLMs need a long-term memory, and why you guys here at Pinecone are in business. So with this notion of a vector database or memories, in order to fight hallucinations, a lot of us have put their faith in retrieval augmented generation, or RAGs, right? And an example of this is a question answering chatbot, where you have a question that comes in, gets fed into a nice embedding, it goes to a vector DB, comes out with the right set of chunks, and now that you know that these chunks are part of your ground truth database, all that your LLM has to do is to just summarize it nicely and come out with a response. So RAGs are kind of, for a lot of people, the answer to hallucinations. But RAGs can hallucinate too. So going back to my vanity queries. We built a chatbot using LangChain, thank you, Ankush, and Pinecone on just asking questions about TruEra. And at this time, at least it got close to knowing who I was, which is nice. But then it comes up with this extra answer, which I would like to have been, which is I am a member of the Bank of England's AI public-private forum, which I never was. So what went wrong? Let's just hold on for a bit for the answer to that question. So in order to kind of really test that RAGs are hallucination-free, I think of testing this thing called a RAG Triad. So you have a question, you have the response, and you have the context that gets fed into it. And then you need to test for the three sides of this RAG Triad. The first thing you need to check for is the context relevant to the question which was asked, the thing that you got back from Pinecone. You need to check for groundedness, which is the response actually supported by the context. And then the third thing is what you summarize and give an answer to, is that relevant to the response. So if you can really close the loop on this triad and make sure that you're doing the right things, it's just possible to get a much tighter handle on hallucinations. And we'll see a bunch of examples on how to do this right. But just doing this right requires a huge amount of experimentation. Like you have so many things you can tune and tweak. But the way you do it is that you build a version, like Matt said, you try your 5 tests and you then say YOLO to see how it is doing. So you really need to iterate with your prompts, parameters, and fine tuning. And I think the last panel did a great job of showing that there's a real gap in dev tooling to evaluate your LLM experiments, especially in that initial phase when you're really learning what works and what does not work. So we built this tool called TruLens, and we're just starting out with this. So would love for you guys to bang up on it and let us know if it's doing anything useful. But essentially, as you build your LLM application, you start logging everything that you're doing to TruLens, and the way you do this is just with one line of code. You just wrap your LangChain Llama Index app, what have you, with TruLens, and then that just automatically starts logging everything you do. And then you add feedback functions to it. So we'll talk about feedback functions in just a bit. But essentially, once you do this, as you iterate through your prompts, you can just make sure everything that you've done is logged and then checked again and again as you tune your prompts, you tune your parameters and so on. So you're not doing 5 queries and YOLO. So that just lets you pick the best version that you have. And what is a feedback function? We talked a bit about what your automated LLM-assisted evals are. So it's just a way to make sure you have a unified framework for collecting all of the feedback, automated or human, in one place very quickly. And the 3 most important things in the triad we talked about before are 3 great examples of feedback functions. And then you can do a lot more with it. You can check for sentiments, you can check for guardrails, you can check for toxicity, and make it very easy to wrap this stuff and make sure it all works, and it's testing all your apps. So just going back to this question of what have happened in my a vanity question of who was Shayak. So it mostly gave a great answer, right? Where Shayak is a computer scientist. I'm glad I didn't introduce myself before, so that I'm letting this app do it. So I got my PhD from CMU, etc., etc. But then this weird last part is wrong. And when you look at what happened here, what Pinecone sent back, and at no fault of Pinecone's, it sent 2 documents about me and 2 documents about a friend of mine, Shamik, and then the LLM very nicely just combine all of this into a great answer and sent it back to the user. So in that triad, the 2 things that failed were context relevance, because the context did not really fully match the query, but then the response didn't fully use the context correctly. So there's a failure of groundedness, which is, does the response map the context on it? So here we're just starting to see how just going through this triad for your different examples can really tell you whether you're hallucinating or not. So the cool thing is that sometimes hallucinations can actually be correct. And this is another hot take, where we build this, and this I think is a Pinecone starter example with LangChain, which we love using, where you use the simple Wikipedia text, and it goes through LangChain and Pinecone for like a question answering system you can build in less than 5 minutes, which is really, really cool. But essentially, I asked it, name some famous dental floss brands, and it gave me the right answer. It was like, there's Oral-B, Colgate, Glide, Dentec, which I hadn't heard of before. But over here, it just turned out that all of the context which was retrieved didn't have this answer in it at all. So even though the answer is correct, it was made up by the LLM, but not from the context. So this is kind of an example where hallucinations can often also be correct, but the place where you failed in that triad was in groundedness, which is that the answer you made up wasn't really supported by the context. Or you might really just be answering the wrong question. So another question I was interested in asking about is, which year was Hawaii State song written? In this one, it just answered the name of the state song. And the interesting thing here is that the context has the answer. It could have done a good job, but the answer itself is not relevant. So just being able to check this whole triad really well just makes you able to tell what part of this whole chain you're going wrong in. So getting this right really requires experimentation. So one of the things you can do with TruLens is to make sure, as you're doing these experimentation, playing around with parameters, you can log everything, run the same evals, and then you really pick which one is the optimal model for you. You can just, all right, I tried a bunch of embedding tools, I tried a bunch of context lens and so on. The one that works the best for me is this Chain 5, which also happens to be the least cost and the fastest of the apps in here. So this is just getting a bit more into the workflow of being systematic and doing evals as you're doing your experimentation, which is what we were talking about in the last talk. So, I mean, we talked about these general tasks that are quite important. So we talked about summarization, text embeddings. Inference is what we use in the feedback function itself. So these are all these tasks which are like trained and LLMs are designed to be good at. One of them, which we didn't cover, which also can be super useful, is planning. And that's what you use for agents, but you can also use that to improve the context of in your triad. So one of the cool new ideas to improve how well RAGs work is agents for question answering. And you can take your question and plan out what other questions you want to ask to then understand what other things you need to summarize to create a response. So what this allows you to do is to ask a lot more complex questions about your document. So in this case, I built out this app with Llama Index and Pinecone on Alice in Wonderland, where you're allowing the RAG to answer this really complex question, which you can't really get from like 2 pieces of context, which is, I have these 3 separate chapters in Alice in Wonderland, which I want to compare and understand what the sentiment of these are. So it's a really complex task. But essentially what I can do here is, by breaking it down into these questions, I can really do a much better job of answering something like this. So it can take a lot longer because you're doing a lot more work, but you're going to get a much better answer because you're really improving the context relevance in this example. That's going up because you have much more complete context. You're letting the LLM decide how much context it needs and why. So this is just another thing that LLMs are designed to be good at, that you can leverage to improve some part of that triad. And when we kind of experimented with query planning here, and you can use this QR code here in the bottom to look at exactly how well this works. It's essentially decomposing a complex query into separate questions, and it does a lot better than if you were doing just straight up retrieval without planning. And it takes longer, it's more expensive, but you get to nicer answers. So yeah, just to recap, essentially the hot take I just started off with was that LLMs are trained to generalize, and they sometimes happen to hallucinate as like a side effect. But there is hope. There is hope that we can get towards a hallucination-free RAG world by augmenting LLMs with long-term memory, which is all the awesome work that Pinecone is doing to make sure this is faster, better, more accurate, and then creating workflows that evaluate RAGs carefully. So, and that's something you can do with TruLens and a bunch of other cool tools which are out here in the space. So I'll just leave you guys with this Squid QR code for you to try things out and let us know if this works for you or not. All right, thank you so much.
Someone asked if you can go in a bit deeper on agents, how to break down the query into a subquery.
Yeah, I think there's a number of different ways to do it, but one of the ways this subquery question answering thing that Llama Index has is by giving it the question, giving it the sources it has in a prompt, which is these are the sources you have access to, and then asking the LLM to decide, okay, what are the next layer of questions you need to ask to make sure that you get a full context of what's going on here.
Do you have any thoughts on using agents to evaluate for relevance and groundedness?
Absolutely. I think it's going to be a lot more expensive. You spend a lot more time doing this, but you can have a lot more access to resources and agents, especially to create questions that you need to ask of your LLMs to get to a more comprehensive test set. So yeah, the agent approach can do a lot of cool things in terms of making sure you have good evals.
Do you have any advice for chunking or for chunk size and chunk overlap?
No. so yeah, I mean, so the main advice I have is to experiment, because it's just, for some use cases you'll see fewer chunks, smaller chunks work a lot better. Other use cases will have bigger chunks. It's hard to tell without knowing what you're doing and your specific use case, what parameters will work well. So it's just important to systematically go through these options and evaluate them to make sure you have a good answer to that question.
All right. Thank you so much.
Thank you so much.